Okay, so if you didn't know, chessboards are like dumb expensive. I mean, seriously, it's like $100+ just to get a nice chessboard. Now, so you do want to actually play chess and you have the money. Well, you might as well just go buy a robotic chessboard, right? No, they're like half $1,000. So we come to this dilemma. How do we play chess in person without dropping our Roth IRA on it? Well, most would think, let's just go play on chess.com. But no, you're weird. If you play chess.com, suck and have no friends. But what if you have no friends either way, like me? Well, I think what we should do is we make my 3D printer play chess against me. We have 3 axes that we can use. We have build plate that we can put a chessboard on. It'd be easy. We could play chess. Really easy. Alright, I might have already started building it, or actually I finished it. So yeah, let me just go ahead and show you this amazing piece of technology that I've engineered. Alright, so, bam, here it is. Alright, if you can see, look at this. Absolutely amazing. Now, let me just go ahead and show you the full design. So basically, first we have the grabber. Now, this grabber is very, very nice. Just watch this. Do you see that? Yeah, I know. The gripper moves. It's pretty sick. Now, if you're wondering why it moves so easily, I stole some Vaseline from my sister. Alright, next up, the pieces. Now, you're wondering, why do these look so amazing? Well, actually, the pieces are one of my brilliant designs. I went ahead and printed some cubes. Now, you're probably thinking, how do you remember where all your pieces are? Well, that's the thing, is that you actually do have to remember where they are. So every move you make sure you remember whether it was a pawn or whatever. Now, this could be updated in further designs, but I'm too lazy to do that. So to see the chessboard, we're obviously going to use the camera facing straight down on it. Now, there was probably some other views that I could have used, but the reason I did this is that when the chessboard goes to its reset position or its idle position to make moves, which is the maximum distance that the build plate's able to move, this camera is actually going to get a top-down view on it. And that top-down view is basically going to snap an image. Now, this is going to be the same sort of process that you do when you open up like an app to scan documents, is that it's essentially going to use something called homography, which transfers one perspective of an image to the other. So even though this is not the perfect orientation of the image, I'm able to take the coordinates or the points on one matrix from the perspective and orient it to another. So we create 2 different perspectives, and that second perspective is going to make it a flat image. So now you can see that when I move this around, it looks normal. Everything starts to maybe, actually no, it looks completely like I just have a top-down camera on here. However, once we apply homography, you can see that it's a flat image, and it actually looks really sleek and cool. So I know you're just dying to know how we actually connect to the 3D printer. So it's actually quite easy. If you haven't heard of it, there's this little thing called Octopi, and you can download the Octopi OS onto your Raspberry Pi. It's a really small computer that fits about the size of my hand, and it's kind of cool. So how do we actually use the Raspberry Pi? Well, essentially, we have a Raspberry Pi right here, right? So RP, Raspberry Pi, which projects a signal. So we know that this Raspberry Pi is connected to the 3D printer via micro USB, so micro USB, sick. Now, it's connected to here. And we know that, again, a Raspberry Pi projects a signal, so bing bong right here. We can actually SSH, which means just to like wirelessly connect into a network, like a fancy term for it, I don't know. And we can get full access into my Raspberry Pi and its OS. So since we're able to access it over the air through like its little network, I can actually control the printer and all of its axes. So we can use the API that Octopi has, and we can use Python, and we can also use OpenCV to actually use the camera. So we have 2 different portions here that all essentially help us make the board move. So to actually use Octopi, all you have to do is go to octopi.local right here, and we have all the controls that'll be connected right to that 3D printer. So when I click the move button, it moves. Isn't that sick? Now if I go up, that goes up. If I go down, it goes down to the side. It's sick. That is how I'm actually moving. Now, here's the coolest part. It uses Stockfish. I know, it's so sick. Literally, it uses Stockfish. This is going to beat Magnus Carlsen. So suck it, Magnus. You can't beat my 3D printer. Now, I was able to implement this using a Python library that's actually made by Stockfish. And we just combine that with the OpenCV and the API, and it all pulls together to make a beautiful, actually it's terrible code that I have right here. Now, if you want to take about 2 seconds to look at it, it's just bad. Okay, so it is time to test it out. I have the board set up, ready to go. We got all the pieces on there, and everything should be good. So I'm just gonna go ahead and click the main.py start button, and that's going to initialize the program with a picture of the board. So as you guys can see right here, we have our emptiness. So let's now go ahead and make a move. I'm gonna go pawn e4. Easy money. We'll go ahead and click me on here. So Stockfish recognizes that, crap, it failed. 1 second. Okay, so back in business. All right, we got it working. Stockfish, go ahead, and he picks whatever move that is. E5, easy. Whoa, what does any of this actually even mean? Well, to begin, this is the board that's scanned. O means occupied, E means empty, and these are squares. It's an 8x8 matrix. I love NumPy. Anyways, this is a real chessboard, like alignment or whatever. It's the ASCII, or it's the algebraic. Wow. Anyways, that's what that is. And then every time you make a move, it'll update it here. And then, yeah, it's the game begins, grabbing image. And then when you're ready to make your move, you click me. It's amazing. Clicked. Failed. So, moving e5. Look at this. It's beautiful. It puts it down. Oh my god. It's amazing. Look at it. Oh, yes. Good. And voila. So, why not do a whole round? Well, that's the thing, is I actually don't think it'll work. So that's your guys' job, is I'm gonna put the code in the description, and you guys can put it on your printer and test it out. But I don't think any of you guys are actually gonna do that. So, yeah, we're just gonna leave it here. It's more of a proof of concept, and I think it'll work, except I just don't have the time to actually make it entirely work. I promise it does though, I promise it does. I've actually beat Stockfish from this thing. But as you can see, here is living proof that I made something that can beat Magnus Carlsen. And yeah, so that's the video. Make sure you smash like, and yeah, thanks for watching.